Continuing my theme of British home wiring, I thought I'd take a look at the lighting circuit. And surely the lighting circuit can't be that different around the world, but it depends on whether your country uses ceiling roses or not. So this is a device that screws up to the ceiling. It's basically a junction box just purely dedicated to lighting. It's got a screw-on cover and it takes these pendant lights. You can get a wide variety of fitments for these, but typically in a bare new install, you might have one of these ceiling roses in the ceiling of each room and a pendant hang from it with a light shade screwed on. And these can actually take a fair amount of weight. But the main thing about them is they simplify the wiring greatly, and I can demonstrate that with a doodle. So let's bring in a notepad. Actually, let's bring in a bit of paper here. Let's bring in a piece of paper and I'll tame the exposure down just a very tiny bit. That should be good enough. So the classic lighting circuit all around the world is you've got your live feed. It comes through protection, say for instance a fuse or a circuit breaker. I'll just draw a fuse in this instance. It goes through the light switch to the light fitting, which is I'll just draw as the classical tungsten lamp, even though it's really old-fashioned now apparently. And that's the neutral. And if the light fitting is earth, that will be connected to an earth connection. That's fundamentally it. I'm just going to focus down that, just make sure it's locked solid. I'm just going to also play with exposure. Is this going to go horribly wrong? No, it's working. It's fine. So beyond that, if we look at the classic arrangement of wiring in a British house, say for instance we draw a very, very simplified house with just 2 rooms. So there's the 2 rooms with a divider between them. And we've got the front door to the house, opens that way. And there's a light switch just as you walk in. In this room, let's make the door open the same way. We have a light switch here. And say for instance, we've got we can go through there as well. So we put a light switch there as well. So we've got 2-way switching in that room. And as is common in Britain, you'd often find our consumer unit, a very small electrical cabinet somewhere near the front door. So in the middle of each room, you'd have one of these ceiling roses. And the circuitry would be so simple. A cable comes from the consumer unit, protected at about 6 amps with a circuit breaker. It comes up to the first ceiling rose, and then it loops to the next ceiling rose. And if there were more rooms, say for instance the house would extend out this way, and they added a couple more ceiling roses, then it would just keep looping from ceiling rose to ceiling rose until you'd covered every light circuit in that level. Typically in a British home you'll have the ground floor lighting and then the second floor lighting. And then from each of those ceiling roses you just have a cable going down to the switch. So that's one cable going down to that switch. In the case of this one with 2-way switching, you'll have a cable going down to that switch and then another one linking that switch over to the other switch to allow the 2-way switching. And the 2-way switching is very straightforward. It's one of these things that often trips people up, but it's actually very simple. If you have a switch that can toggle, so we'll call this the common terminal. It's a bit tricky here because different manufacturers use different names, the different terminology, but let's just call it the common terminal. And typically these would be marked L1 and L2. And it can either switch that way or it can switch that way. So you've got your switch feed coming down from your ceiling rose, you've got the live, and then this sort of switched wire going back up. And they would just come down and they'd go on to those 2 outer connections, like this. And that would then continue across to the other switch. And then the middle connections, the common connection would just be commoned across like that. And now no matter which way you switch these switches, you'll be able to turn the light on or off from each switch. And if you want more ways, all you do is add an intermediate switch, which has 4 terminals, 1, 2, 3, 4, and it will either connect them across the way it's shown, or when you flick the switch, all it does is it reverses those. So that it toggles those 2 lines either straight through or crisscrosses them. You can have as many as you like. So that's fundamentally it. So let's take a look at the ceiling rose and the wiring. Let's take a look at everything, in fact. Let's just take a look at it all. The ceiling rose, let's see if this one's any clear because it's got a cleared case. We'll brighten this up now a little tad. It has 3 sets of terminals plus an earth terminal. It's got the neutral bank of terminals, 3 terminals for neutral. I'll just zoom down this just a tiny little bit. It's got 3 terminals for neutral, it's got the 3 terminals for what's called loop, and it's got 2 terminals for live. And really, the live there should kind of say switch, shouldn't it really? But either way, the supply comes in, and I guess this is ultimately why this one's called loop. It loops in through the live loops in through this terminal and then back out again. Likewise, the neutral loops in through this terminal and back out again. So that's 2 terminals taken from each. And the wires for the earth, once you've finished everything, you just bunch everything together for this one earth terminal. The switch wire, which is going to be used to actually switch the light on and off at this position, loops in between the last connection here, the loop, and goes down to the switch, comes back up and goes to the live here. And the light then, the actual pendant, will connect between that live terminal and that neutral block. And what that means is that you've got a continuous feed looping through this, and when you actually flick the switch, then this block comes live and it feeds the light. And the way this is arranged, when these go in, you've got these sort of mounting sort of posts here that when this is terminated, you can hook the wire underneath and take it over to the middle, and with the correct sizing, it will act as a sort of strain relief, and the flex will be held roughly about this height. If the cable's too long, you end up with the wires showing down like this, which isn't very good. This is one of the lesser aspects of these things. It's just, it's not a great grip system. Other versions of these sealing roses, you get a little grippy thing that slides over. You squeeze it, it slides over, and then when this pulls on it, it actually locks and grips onto the side of the cable. You have to allow for the fact that people will put very, very heavy lights, like big Tiffany glass lampshades in these things. The inside of the standard bayonet cap lamp holder here, which has springy pins, and the bayonet cap mechanism here, the inside of the back of it has 2 terminals, and then it's got little grips that you can terminate it into that, loop it round this little lug here, and then it sort of acts as a sort of strain relief, and there's just enough room in the top here that it's going to sort of hide that cable and hopefully stop it from poking out the top. All a bit vague, is it not? But it works, and it's worked for some considerable time, so why change it? There are improvements. Let's zoom out a bit. If you've got more than one light, if you've got in a room, you want 2 separate ceiling lights, all you do is the outer terminals, you loop another wire in and out. And so the feed that's actually going down to the lamp here can also be taken across to this other ceiling rose with a piece of cable. And this is the cable we'd normally use. It's called Twin and Earth. And this is a 1mm squared cross-sectional area cable. And it has the brown live conductor, it's got the blue neutral conductor. You can get versions that it's got 2 brown conductors, and you could also get versions brown, black and grey. But typically the most common version is brown, bare earth wire in the middle, and blue. And you'd have a sleeving that you slip over that. I believe in Ireland they're changing that. They're potentially going to have the centre core sleeved with PVC as standard along its full length. I'm not so sure about that, because one of the ways that you strip this, let me show you this. Typically how I'd strip this cable is I'd have a sharp knife, if it's not been banned from the building site, and I'd just ride it up against the earth wire and just slide it along, and that strips the cable. You're not going to be able to do that with their approach. What you're going to have to do instead is you're going to have to ring it round, I guess, and then slit it that way to actually get that, because at the moment it's quite advantageous having that earth wire. One of the things you're not supposed to do is, what some people, when they strip this, they get a pair of side cutters, snip the end, grab the earth wire and rip it along to actually break the insulation. I don't recommend that. I prefer using the Stanley knife, even if we're not really supposed to use them in many sites these days, in case we hurt ourselves. Thanks for that, health and safety. I feel so much safer now. I wonder if one of the reasons in Ireland that they've chosen to go with the direction of the sleeved centre core is the fact that you do get some complete plums who stick a brown sleeve over that and use the inner core as, as a live feed down to, say, 3-way switching, 2-way switching, just because they can't be arsed getting the right cable and because they don't know any better. Fortunately, those builders are now all fully certified Part P electricians. So well done, NIC, EIC. Glad you made lots of money there. So moving on to the switches. Hold on, I'll get some stuff to show you. So I'm just going to grab those right now. This is a good time to introduce all the different sort of boxes we do. For surface mounting, you get the plastic Patras box. This is going to be nothing if you live in America or Canada or other countries that use the completely different shape boxes. This is our standard single gang box. This is our standard sort of double gang box. It's just a completely different style, much shallower and much wider. In a way, I don't know, but you can let me know in the comments below if you think they're better in a way or worse in a way. But typically you have these available in various depths, and one of the most common ones, unfortunately used for lighting, is the 16mm deep one. And this one has, because you can't actually fit a standard 20mm knockout in it, this one has this whole sort of punch through, and it's quite clever. They've punched it through in a way that it forms a sort of soft rounded edge there. It's quite good. It's also got a built-in earth connection. It's very, very shallow. It leaves absolutely no space. Once you've got this switch into this, and the main advantage of this is that for builders who want to save time, they can get it just banged straight on the wall before it's been plastered, and they can run a bit of oval trunking down, or they can put a capping down, and it means that they don't need to raggle into the wall, they don't need to cut into the stone, they can just basically screw it straight onto the wall, and then the plaster will come along and he'll like plaster up to the surface of the switches, and also that makes the wall look a lot smoother. The downside of that is that these shallow boxes, if the plasterer puts it just up to the edge of this, it doesn't leave a lot of room inside the wiring. It really is very tight for space in there. It means you have to route the cables very carefully, sort of basically come out and then tuck them hard down the side. And it just means it's just that little bit harder to wire, particularly if you've got, in one case, like near here, I did have an electrical incident recently, which was a multi-way switch in one of these super thin boxes. That is a story in its own right, though, because it was a very interesting electrical fault occurred in this house that was very connected with the TT electrical system, and also relied on three things happening at once in just coincidentally together. That made it a very hard fault to find. That was really interesting. So these are we've got different depths of boxes. We've got the 16mm, we've got the 25mm, that's about an inch, we've got the 35mm, and we've got the really deep 47mm for things like, say for instance, shower isolators and stuff like that you've got quite a depth of the mechanism behind it. Keep in mind that if you're wiring your own house in Britain, that you're not better going for these boxes, because with the trend towards putting electronics in the back of things and dimmers, in many instances you just won't be able to fit a dimmer in this. You'll have to actually have a packer plate that comes out the front to actually pack the dimmer out from the wall so it can actually fit into the back of this, or you'll have to remove the box and start raggling into the wall and then plastering around it and trying to touch up the wallpaper. And no, not a good idea. I recommend choosing a fairly decent box, a very minimum of the 25mm. Maybe if you're considering active electronics, just go deeper. It just depends how much time you got to actually prepare the wall. If it's plasterboard, sheetrock is it called elsewhere, this is the type of box you'd have. You've got these sort of loose lugs. You cut the hole for the box, you place it through, and then you lift these up and you click them through like that, and then you can just grip them and pull them up so that it sandwiches the plasterboard. And as you actually tighten a screw into this, it pulls this yellow wing up and sandwiches the plasterboard in between and grips so the switch is actually pulling in this way. The socket, the screw that holds it on is pulling the yellow up the way, and it basically grips the box into the plasterboard tightly. This white surface mount box is it's very brittle. You do get softer ones. This is the brittle type. It's designed where sockets and switches are going to be mounted in the surface. This is a double gang one. And these ones, where you've got a cable coming down, you've got these knockouts that, I say knockouts, shatter out might be a better description. It's very brittle plastic. It's not really that well designed. You have to nibble away carefully at them. If you don't, then it can shatter, and sometimes the whole box just splits in half if you're being very impatient with it. So let me get some switches and show you some of the options we have there. The switches are invariably available in one-way, two-way and three-way switches, and typically most of them are supplied as three-way switches, should I say three-terminal switches, two-way switches, that will switch between a common terminal to two other terminals. And one of the most common electrical incidents, little accidents, DIY things that goes wrong, is that people disconnect all the wires without marking things properly, and then they could end up with an absolute ton of wires behind this switch, and if they don't know where they go, it's a bit of a puzzle to actually work out what they are. You actually have to start tracing cabling. If everything goes horribly wrong, if you screw up, or if you have to make an exploratory hole in the wall because a cable went missing, this is a blanking plate that can also go in place of a switch plate, just in case you have, well, a way to cheat if you had to fish into a wall is to use one of the, if it was say a plasterboard, it was a hollow wall, you could put one of these in with a blanking plate in the front. It just neatly covers up a hole that is used for exploration or might be useful for accessing cables later, but it's usually to cover up something that has been removed, maybe something that's a redundant switch that's not used anymore. Or you could actually have electrical junctions behind a box like this if something's being moved. The brands of switches, here's a typical, what brand is this? This is Status. And what's interesting about this is that you've got a screw here, that if you undo the screw, and this isn't, this is just how they're manufactured, it's not really anything else, but if I flick that switch over, you can physically remove the module. And inside is really, well, let's take one of these to bits. Let's find another thin screwdriver that I can lever this with. Where is the other screwdriver? I have misplaced it. It's buried. Not to worry, there it is. Let's see if I can do this without breaking it. The chances of me breaking it are probably very high. I'll probably regret this completely. So this switch will almost certainly have a little springy pin out the back, the way these usually work. Oh yeah, there's the springy pin. It's not revealing an awful lot. It's revealing a little plate in there. Does that come out? I'm trying to work how this has been made now. So the switch itself has a spring-loaded little pin. I'll zoom down so you can actually see us a bit better. The pin is spring-loaded and it's pointy, and it basically rides over the contact plate and rocks it backwards and forwards. The contact plate is actually fallen out. That's not good. It's okay. I can rebuild it. Maybe not, just the crack that made. I'm not too bothered, it's just a switch. Let's just dig into this and get it out. I don't really see how this is held together. I don't know if it's partly held together by the... Yeah, I think I'll just use brute force and ignorance. That's often the best thing. I have plenty of switches, it's no great deal. This one can sacrifice itself for the greater good. Ugh! It might sacrifice my finger for the greater good as well if this screwdriver slips. That is not coming out, but that's okay. We'll find out when it does come out. All right, I see it's kind of looped. It's actually hooked under the tabs at the end there. Yeah, this is turning into a complete destructathon. There we go. We have the common terminal, which has the little rocker bar on it. Can you see that little rocker bar at the bottom? And that's what this contact. It's guided in by a couple of guides at the side, and it can rock on that rocker bar. And it goes in between these two connections. So in one direction, the little plunger will make it click up the way. And in the other direction, when you click the switch the other way, that's what gives the switch its nice decisive click as well, but clicks it down to the other contact, so it switches between those two contacts. I shall put that slightly decimated thing away. Fortunately, to actually put that back in, if I need a two-way switch, I can actually just move this module to that one. And the connections in these switches are labelled. Let me just put that screw in there. No, you know what? I'll get that later. That's me just trying to avoid losing screws. I'll put everything in that switch. There we go. And I'll zoom back out again. So the connections in this are marked COM for common and L1 and L2, and typically, but not always, it will be COM and L1 are the contacts you want. And if I go between that with a meter and switch it down, you can hear the continuity beaver going. And if I switch it to the other connection, that sort of reverses it. And that's that. But if you look at this switch, let's pop the lid off this one and see what's underneath it. This one has the common connected marked as L1, and the two switch contacts it switches between as L2 and L3. I wonder why. Maybe they've been changing things in the regulations unexpectedly. That happens from time to time. So what's this construction like? Ooh, this time that has sprung right up. It's the same type of arrangement with that plunger, which I may be able to actually show you now. Let's zoom down on this. So if this cover's in place and I switch, you can see, oh, it's maybe going a bit too far. You can see that switch contact clicking up and down between those two connections. Yeah, someone's just gone into orbit. Well, I'm leaving a trail of destruction, haven't I? It's Destructotron tonight. Not to be confused with Mike's Electric Stuff's Destructotron, which is much more destructive. So typically you've got 1, 2, 3-way switches with these 2-way, 3-terminal switches in them. But you also have the intermediate switch, and that's identifiable by the fact it's got these labelled L1, L2, L3, L4, these 4 connections. And that's for the one where your 2 strappers come in when you're using multi-way switching, and they come in and they pass through the other side. And the common wire that goes between the 2 outer, if you look at the original doodle I did, it doesn't, it just joints through with a terminal in these boxes. It's only the 2 outer ones you want to break. And what happens here is that in one position, let's see which position it's in the standard position, L1 will be connected to L2, L3 will be connected to L4, but when you flick the switch, it will connect those diagonally instead. So they're not connected straight through anymore, they're connected diagonally. So not straight through, diagonally, and that's how it does the multi-way switching. By swapping the strappers, things worthy of mention. Okay, so those are the switches. If you want more switches, you can get double gang, specialist double gang switches, which have a lot more ways. Or you get the things like the grid switch system by MK, which is available in really large boxes. And it has, you can customize it. You can put indicators, you can put buttons, you can put switches, and you can customize the panel, all based on a sort of standard format. It gets quite intense, the wiring behind those. Right, tell you what, I'm going to grab some other stuff. I'll be back in a jiffy. So there is another fairly common type of sealing rose, and it's used in sort of commercial environments where they want to be able to actually just have a sealing rose mounted onto the side of trunking or something like that, and be able to just plug into it. And what they do there is it mounts on all the sort of same sort of fixing arrangements, but they have a plug-in sealing rose. So you've got the connections in the back, you've got the earth connection, you've got the loop-in connection, you've got the switch live, and you've got the neutral. But in the case of this one, you can actually toggle it around like this and unplug it completely. Now looking at this, that pin is central to these contacts. And the only thing that really stops you from putting it in the wrong way round is this little plastic fin here. And you think, well, that's okay because it's not letting me put it in. Oh, there's also this plastic pin. That's not so bad. It lines up with that, because otherwise, if the typical ham-fisted person tried to force that in the wrong way round, if they did actually manage to get that in, if these 2 pins failed, it would allow the, well, what would that be? What would the earth? The earth would go into the permanent feed. That wouldn't be good. But anyway, it's unlikely to happen if the person doing it is careful. So that's the pluggable sealing rose. But what if? Oh, incidentally, it brings, you can get them with 3 cores, or you get the auxiliary core, you get the sort of unswitched feed. And what that's for is for things like emergency lights, where you want a continuous feed as well as the switched feed. Put those down. So supposing you don't want a sealing rose in the ceiling, what you can do then, you can take existing wires that came to the sealing rose and you can put them into a junction box like this lovely Wago box. I do like Wago boxes so much. There is an older style of junction box you can get, but these are designed for applications where you can poke it through a hole in the ceiling to get out the way. In this case, you've got a choice of the push-in terminal blocks. I did a whole video about the Wago terminals. If you want to actually see more about these, just type in Wago, W-A-G-O, on my channel and you'll find it. But they do these ones that you just push the wires and you strip them, push them in, and they bottom out the end, and it makes a strong electrical commoning connection. Or you get these ones with the little release catches, and these can also take the stranded conductors as well as the solid core. I prefer the releasable one, it just makes it more versatile for the future. But the nice thing about the Wago box is you can pre-wire it, and then once you've got these connections all on and wired, you can then sit it in. It depends, you've got different positions for the cable grip for holding onto that cable. Also, with the lid open, there's a bit of flexibility here, it lets them part. So when you sit the cable in, that parts, but when the lid is closed, it pulls it together and it just grips tightly onto the cable. The setting you'd use in that is just whatever you wanted for the thickness, or you can actually remove the fin completely for even thicker cables. The terminals, simply, once you've connected it with the wires in place, you can drop the terminals down these little supports with the wires, and it keeps everything neat inside the box. It's a very, very clever system. And then when you close the lid, everything is secure. It grips the cables. You've got the option to put a cable tie around here. Not quite sure why that is. And also you've got a little lug here that if you can screw a stud onto the side of some woodwork, you can actually sit this on if you can gain access to it. For applications where you're perhaps working, you've got an existing pendant light and you want a downlighter or something in its place. If you had a downlighter like this, you'd cut the hole for this and you can use the thinner Wago box. And the thinner Wago box has it's not got a place for the terminals other than the void inside, but it's got a grip at each end, and it means that you can run the cables in from one end, then it flex out the other, coming out to the GU10 light. And then because of its size, it just literally clips together and just pops up through that hole, and you can tuck it safely out the way up above that and just bring the cable over to your GU10 fitting. So that's the lighting circuits in the UK. You know, it's a very straightforward modular approach. The ceiling roses, once you've got used to wiring them, once you've got over the fact that, you know, particularly, I hate these ones. Like, this one's got a nice big void in the middle. These ones have these little sharp, brittle knockouts that they knock out and they leave a jagged edge. And when you bring the cable through, it always drags in the cable and it's quite awkward to position it. I think I prefer this one for the fact it's got much more space, and also the fact you can pretty much see that the wire's going into the terminal okay, because that's clear. They all have that slight downside of just having one sort of token gesture earth terminal, but that's okay, as long as you've got earth continuity through, and the option for an earth cable. This one's tiny, the earth connection. This one's much bigger. This one is so much better. What brand is this? Volex, and this one is Click. But yeah, it's a very modular system. It's very straightforward. It is just that simple. You know, the cable comes from the distribution board, loops through all these ceiling roses, and from then you can just wire the place as you like. You know, you can, if you want to extend the lighting in a room, you can use this as the main hub, electrical hub, for maybe having downlights all around the place after that. It's very logical. The one thing that people make the mistake with when they put the junction boxes in is they think all the live wires go together and all the neutral wires go together. In the case of the switch, if it's not marked, if it's got the sleeve is dropped off, if they put this to the brown to the live and the blue to the neutral, and it is the switch, then everything's fine. They'll walk into the room, if the switch is in the right position, they'll turn the power on, their lovely new light fitting will be lit with the junction box safely above the ceiling, and they'll turn the light switch thinking it's going to turn it off. They'll be allowed, bang, the power will go off, because all they've done is short the lighting circuit with the switch, because they mixed these up. So that's a common thing. It's not uncommon at all for people to just basically all the blues together, all the browns or all the blacks and reds in the old colour code, and have that problem. So if you ever do that, that's what you done wrong. So the ceiling roses and other stuff, it's a very neat system.